All right. So yesterday we left off in 5.1, part 1, converting polar to rectangular. So we're going to finish 5.1, part 2, and that's converting the other way, rectangular to polar. Okay, first thing is we want to just make sure we remember what they give you in each formula. In rectangular, they're going to give you two numbers. What do we call each number that they give you?
X and Y.
They're going to give you an X and a Y,
R and theta.
and you have to change them into an R and a theta. All right. What does X tell you when you are describing where a point is?
Left and right.
It tells you the position of it horizontally. Yeah, it's the left and the right. What does Y tell you?
Up and down.
Y tells you the position vertically. It's the up and the down. So what I need to do is figure out how far up I go to get to this point, and how far up I go is going to be my
Y.
Y, and then I need to figure how far to the right I go,
And that's your X.
and that's my X. Those are the two things I have to figure out. All right. Oh no, those are the two things that are going to be given. Now the two things I need to figure out is what is the radius. So imagine putting a circle right there. The radius is really something else in that triangle. It's the hypotenuse, yep. So to find the radius, you're going to need to find the hypotenuse of that triangle, which we'll talk about in a second. And the angle is the amount of rotation to get up to that point. That's that angle in the triangle, right there. So you need to figure out the two things that I just circled, the R and the theta. That's the goal. Any question on what the goal is? So now we're going to figure out how do we do that with what they give us. Well, let's start with R. If they give you the X and they give you the Y, what theorem could you use to find the R?
Pythagorean theorem.
Yeah, we're going to use Pythagorean theorem. That is how you find the radius. It's the hypotenuse of the triangle. So the formula for R is R squared equals X squared plus Y squared. I'm going to write this down a little bit nicer on the next page. I just kind of want to show you this quick. So R squared equals X squared plus Y squared. So there's your R. And the other thing we need is the angle. What is the position of side X compared to theta? It's adjacent. So that's adjacent. What position is side Y? That's opposite. What trig function has opposite and adjacent in it?
Tangent.
Tangent. And that's the one that we didn't use yesterday. So tangent of something is going to equal something. What do we fill in inside the parentheses for tangent?
Theta.
Theta. So it's the tangent of my angle. And tangent is opposite over adjacent. What side is opposite?
X. Oh, wait, Y.
Y. And what side is adjacent?
X.
Y over X. So that's a formula for the tangent of theta. What we really want, though, is a formula for theta, not tangent theta. So we have to get rid of tangent. What gets rid of tangent?
Cosine. Inverse of tangent.
The inverse of tangent. Yep. So we have to take inverse tangent on each side. Just going to try to put it in right there. What happens when you do inverse tangent of regular tangent?
It cancels tangent out.
That's gone. And what's by itself on the left?
Theta.
Theta. So your angle that you rotate, this part right here, is the inverse tangent of Y over X. So that's really where your formulas are coming from. That one and that one. We need to talk a little more about that one because there's something that can happen. But I'm going to write that down on the next page. So to convert from rectangular to polar, you might not see Y yet, but you should graph it or even if you don't want to graph it, you do need to figure that out. You have to figure out what quadrant your point is in. If you are in quadrants 1 or 4, when you are trying to convert from rectangular to polar, you can use the formula we just wrote down on the other page. Inverse tangent y over x. That works perfect. The problem is you might not always be in quadrants 1 or 4. What other quadrants can you have coordinates in?
2 or 3.
You could end up with a coordinate in 2 or 3. If you end up in 2 or 3, you have to adjust that formula a little bit. You can still do inverse tangent y over x, but you need to add 180. That adding 180 adjusts it so this formula works in quadrants 2 and 3. Because without the 180, this formula does not work in quadrants 2 and 3. It only works, it's the way it's defined in math. It only will ever give you an answer in quadrants 1 and 4. Specifically, if you want to know what's happening, inverse tangent is always giving you an answer between -90 and +90. That's the right half of the quadrant system. It will never give you an answer on the left half, unless you make this adjustment. Adding 180 will give you answers on the other half. Now, that covers landing in quadrants 1, 2, 3, or 4. But where else could you be besides in those quadrants?
Origin.
Well, you're going to be on the circle somewhere. So you're always going to have a circle that has a radius, so it'll be somewhere around the origin.
On the lines.
But you could end up on an axis. If you end up, let's say right there. I don't know the y value of that point, but what's the x value?
0.
It's 0, because you haven't gone left or right. If the x value is 0, and you try to fill in 0 for x, either here or there, what would happen if you try to change x to 0?
0. Just be 0
Well, where would the 0 be?
on the bottom.
On the bottom. What happens when you put 0 on the bottom of a fraction? That's undefined. You can't do that. You can't have a number divided by 0. No, can't do it. So what happens if you're on an axis? Well, we don't use those formulas. We just have to memorize it's one of those answers. If you're on the right axis, it's 0. If you're up, it's 90. Left is 180. Down is 270. So those are like special cases. So now that covers everything that could happen when you're trying to find your angle. In a quadrant, on an axis. Okay, so there's the part of your coordinate, that's your angle. And the last thing you need is your radius. Okay, if you forget the formula, remember it's just Pythagorean theorem. That's all you're doing. And that works in any quadrant. Doesn't matter what quadrant you're in. So that's everything you need to know to convert from rectangular to polar. So let's try an example.
Was it r squared equals? Okay, I got it. Yeah.
So I'll leave that up while we do our first one. Okay, we're gonna do one that's using this formula, and then we'll try one using the other one. 2, -2. Okay. Where is 2, -2? What quadrant? That's in quadrant 4. Right 2, down 2. Not looking for an exact sketch. We just need to know the quadrant. Okay, we are in quadrant 4. What is the formula to find theta in the fourth quadrant?
Tan -1 divided by 6.
So, inverse tangent, and what's going to go on the top?
Y.
Y is always on the top, X is on the bottom. And it doesn't matter which one goes where unless they're the same, like they are here. But in general, you make sure you put Y in the top, X in the bottom. Okay. When I divide -2 by 2, how much is that?
-1.
Yeah, so it's the inverse tangent of -1. And before I hit enter, I'm going to do it in degrees. Okay, I always do it in degrees first, because if you're going to get a nice answer, you'll recognize it in degrees. If you had done that in radians, you would have gotten this, and you're probably not going to recognize that as a nice answer. Okay, so always do it in degrees first. Okay. So I got -45. Okay, it's negative, that's okay. We are going to write it as a positive at the end, but they didn't say we had to right now. Okay, so -45. So that's rotation like that, going that way. Okay, what's the last thing I need to write my coordinate in polar?
Find R.
Find R.
So R squared equals X squared plus Y squared.
X squared plus Y squared. And what is 2 squared?
4.
And -2 squared?
4.
It's also 4. So when we get rid of that exponent, we're going to have to take a square root. And we're going to get the square root of 8. Which, if we write that as a simplified radical, what's the square root of 8? How can we break up 8?
4 times 2.
We can break it up into the square root of 4 times the square root of 2. And what's the square root of 4?
2.
2. Square root of 2. Okay, so there's your radius. So our final answer is R, comma, and then write your angle, -45. Yesterday we learned that there's up to how many ways you can write a point in polar?
4.
Up to 4, sometimes 3 if it's on the polar axis, but that's not on the axis. If I wanted it with a positive angle, instead of going that way, how much would it be if I go that way instead?
No.
So -45 is if we go clockwise.
315.
How much?
315.
Yeah, it would be 315 if we go the other way. You just have to add 360 to that number, and that makes it positive. So that answer is also correct. If it was a multiple choice question, you would not see both of these listed. You'd see one or the other. Any question how we got either one of them? All right, so that was in quadrant 4, so you did not need to add the 180. Let's do this one. Convert to polar. Okay, where's -4 and -5?
In quadrant 3.
That's in quadrant 3. Right about there. What's the formula to find theta in quadrant 3?
You have to add a pi.
Right, if we're going to do it in radians, we need to add pi, or in degrees.
180.
We're going to add 180 first. So put 180 plus, and now you can do the inverse tangent y over x. Now, y and x are different this time, so if you switch the order, it will be wrong. What number goes in the top?
-5.
And the bottom?
-4.
Yep. If you want to cancel the negatives, you can, because it's a negative divided by a negative.
Is it always y over x?
Yes.
Okay.
Yep. Okay, so let's do inverse tangent of 5/4. So there's, well, that's in radians, but let's do it in degrees. Switch to degrees. We have to do degrees because we said 180. That's why. Okay, so we get 51. But then when we add 180, it's going to give me an angle of 231.34. Okay, if you get 51, you should look at that and be like, that wouldn't make sense without adding 180. What quadrant is 51 degrees in?
1.
Yeah, this is 0 and this is 90. 51 degrees is somewhere in there.
And should we be at quadrant 3?
And we're supposed to be over there. So if you don't add 180, it won't come out right. That's 180. That's 270. We got 231. That's right in the middle. Yeah. So 231.34. Okay, so there's our angle. And what's going to be the formula for the radius?
R squared equals x squared plus y squared.
R squared equals -4 squared, which is x. And what's -5 squared?
25.
25. And 16 plus 25 gives me how much?
41.
41. And your last step to get rid of that exponent of 2.
Square root.
Square root. Probably better off to do it like that. If you try typing it in on the calculator, you can, but you would have to type it in like this. Let's do the part under the square root first. -4 squared plus -5 squared. If you really want to use a calculator, that's how you have to type it. And that's how you get 41. If you don't put parentheses and you do this, you are not going to get at all what you're supposed to get.
How does that change the sign? Oh, wait a minute, because I get it now.
One's
So the-
negative.
Yeah, so the calculator is going to do exactly what you tell it. It's going to square the 4 and then put a negative in front of it, right? Versus squaring the number -4. That's different than squaring +4 and a negative after. Okay, so that's why sometimes I don't bother with the calculator if it's more work to type in all the parentheses. Okay, so the final answer is R, comma, theta. So 2. And that's how you change it from rectangular to polar. Okay. Any question on that? Now, if you had a point here, again, you're not using a formula, you just have to know that the answer is 270 for the angle. So what if I gave you just a picture? What's your radius for that point?
180.
3.
Well, that's your angle. Your angle is 180,
-3.
-3.
but your radius is
-3. Or, no.
not with an angle of 180. We can't do that.
3.
3. So you could write it as 3, 180. You can do -3, but if you want to do that,
-3, 0.
you need to make your angle 0. Yep.
Okay.
Right, both these answers are correct.
Now, if that question was on the test, would you want both of them? Or would you
I'd
just-
probably ask for one of them.
Okay.
Yep, I might say, write your answer without negative numbers, and if I said that, then I'd be looking for that. Any other question on that one? Okay, so the last thing we're going to look at is section A4, which is on complex numbers. So first thing I usually do is just kind of look at where do complex numbers fit in to the kind of numbers that we're more used to working with. Because complex numbers, we don't work with that much.
We'll be on the test.
Yeah, this will be on the test. Yep. So when we start out, we're going to just look at the simplest kind of numbers we could have. What's the simplest thing that you can do with numbers? One of the first things you learn how to do?
Count.
Count. Right? And when you count, what number do you start with?
1.
1. You don't start with 0. There's no 0 when you're counting. You don't go 0, 1, 2, 3. You go 1, 2, 3, 4. So you count, and when you're counting, there's no fractions or decimals. Okay? If you're counting objects, you count the object and you don't count. So they start at 1 and they go up. No fractions, no decimals. Next kind of thing you learn to do with numbers is arithmetic. Okay? Once we start doing arithmetic, sometimes counting numbers are not enough, depending on what you want to do. Somebody give me any counting number. 1. And another counting number. 2. So a lot of things we can do with those, and we'd be okay. If we add 1 plus 2, do we get a counting number?
Yes.
Yeah, you get 3, which is a counting number. So addition with those two numbers is fine. How about if we did 1 and we do multiplication? 1 times 2.
2.
You get 2. Is that a counting number?
Yeah.
Yep, 2 is a counting number, that's fine. Let's
But
try
when divided-
subtraction. 1 minus 2. When we do 1 minus 2, do you get a counting number?
No.
No. So that is a problem, and unless we invent a type of number, we can't do 1 minus 2. Could we do division, 1 divided by 2? Is that a counting number?
No.
No. So unless we invent another kind of number, we can't do that kind of arithmetic either. So the next kind of numbers that we invent are whole numbers. Whole numbers don't solve either one of those problems. We still can't do this, and we can't do that. But what we can do with a whole number is this. We can subtract two things that are the same, and we get 0. That's the only difference between counting numbers and whole numbers. Whole numbers have the idea of nothing. They have the idea of 0. Counting numbers do not. All right, so now let's look at this problem. If you gave that to somebody in like first or second grade, they'd say you can't do that. When you do subtraction, the bigger number always has to come first. Well, it doesn't have to come first. It can come second. And you get a different kind of number. You get a number that represents having even less than nothing, right? It's a negative number. And those are called integers. So each time that we expand our set of numbers, we can do more kinds of calculations. And I don't think that that's a very complex calculation. That's still something you could do in everyday life. Like if you buying a house for say $200,000 and you only have 50, well, you got to take what you have and subtract the cost of the house. That's negative 150,000. That means you need to borrow 150,000 from the bank because it's negative. You don't have enough money. So negative makes sense. Businesses lose money. Right? If you made $100,000 in your business and you spent $120,000 for fuel for your car, tools, advertising, you lost money. You're negative 20,000. Okay, so we use negatives a lot. But this would still be a problem with integers because integers do not include fractions or decimals. They only include positives, negatives, and 0. Does anybody know the kind of number that we invent so we can take and do division like that?
The I?
Not yet. I's a little ways away.
Real
Little bit closer, but something a little bit. Real numbers is going to be outside the box. We have one more label inside the box.
Fractions.
Fractions, or we call them rational. Okay, rational numbers. And for most
Yes, get it right.
everyday kind of math, I would say that's probably what most people would use. Right? Rational numbers include parts or fractions of something. Because if you don't have rational numbers, like if I wanted to take these 3 objects and divide them between 2 people, equally, I can't do that. The only way I can take 3 objects and divide them between 2 people is if I break them into pieces, and then I can divide them equally. So that's what rational numbers are. They give you fractions or pieces of a number. Where would you use fractions? Well, most of the time when you buy something, there's a dollar amount, and then it might be like 34 cents. Right? That's 34 hundredths of the next full dollar. Right? So it's a piece of the dollar. When you're cooking, right? You might have to cook, need like 2.5 cups of flour. So it's not 2, it's not 3, it's in between. It's a fractional amount of the next cup. So rational numbers used quite a bit. Next kind of numbers, not used as much, but we have already used these numbers today. If rational numbers are ones you can write as fractions, these are ones you cannot. If anybody know what you call the numbers that you can't write as fractions?
Irrational.
Irrational. And what kind of numbers come up a lot
Square roots.
in math that we can't write as fractions? Square roots. No. The square root of any number that's not a perfect square. So square root of 4, that's different. That you can do. But square root of 2, square root of whatever we had in the last section, square root of, I think it was 41.
41.
Right? You can't write that as a fraction. Another number, really popular number,
Never ending.
7.
that you can't write as a fraction.
3.14.
Repeating.
What is it?
Repeating decimal.
Well, a repeating decimal is okay because you can write that as a fraction of 1/3. So if a decimal repeats forever, you can write it as a fraction.
Pi.
Pi.
3.1419.
Pi, there's no pattern to it, right? It keeps going on forever, but it doesn't repeat the same number over and over. There's no pattern. You cannot write pi as a fraction. It's not possible. Some people say, well, what about like 22 over 7? Well, that's 3.14, but then it changes. Right? That's not exactly pi. So now, if you take all of those numbers and put them together, that's what you learn about in Algebra 1. That's called the real number system.
Did we go over this already this year?
We might have talked about it a little bit, but I'm thinking some people might have
Oh, we
forgotten.
did this on like our first day.
Yeah, I think-
Yeah, okay, that's what I thought. That's what I just said. That we did this already this year.
Yeah, some people might not remember.
Don't look at me when you're saying that.
Don't
Oh,
look
I
at
didn't
everybody.
remember either.
So yeah, so that's again, we'll just do a quick review because we're almost done. So real numbers is everything we learn about in Algebra 1. The problem with real numbers is there are certain calculations you can't do. You can do fractions, you can do negatives, that's no problem, but you can't do that, not with real numbers. Because this means to find two numbers that multiply together to give you -4, and the two numbers have to be the same. So if you try 2 times 2, how much is that? 4. That's not -4. What about -2 times -2?
It's 4.
That's also 4. So let's try it on the calculator.
Why are two negatives multiplied together a positive? I never
Cancel
understood.
out.
Yeah, but like why?
I could show you why later on if you want.
I want to know why.
Yeah, I've looked it up before.
You have a shirt on
Off the top
why?
of my head, I don't know the exact proof why, because it's something so basic we don't think about a lot. But I have looked it up, and once I look it up, I remember the good explanation for it.
We'll do that at the end of class, though.
Yeah. So if we type in square root of -4, let's see what the calculator says. Square root of -4. It gives me an error, but it doesn't say that it can't do it. It just says the error that I'm going to give you is not real. Do you really want to know what the answer would be? And if you're in Algebra 1, probably not. Okay? You don't study anything that's non-real. If I teach the calculator Algebra 2, which basically means change this setting, so instead of working with real numbers, it also works with another kind of number, it gives me an answer. And it says that the answer is 2i.
What's
So-
the other kind of number that deals with? You said it has another kind of number. What does that mean?
Like I is the other number.
There's another option.
Yeah, so when we're dealing with reals, I is the other kind of number that comes up when we deal with imaginary. That's the other kind of number, imaginary. So this I is something that was invented, just like This symbol was invented to represent less than 0. This symbol was invented to mean exactly 0. This decimal point thing was invented to mean a part of a number. I mean, why do we use a little dot to represent a part? Well, some countries don't. They use a comma. We use a dot. Well, that symbol was invented to be able to solve a problem like that. The difference is this kind of problem doesn't come up in everyday life as much as this kind of problem. Fractions come up all the time, but square roots of negatives, no, not as much. Okay, so those are called imaginary. Okay, so there's a couple examples of imaginaries. Now, finally, the kind of numbers we're going to study, complex. Complex includes everything. So if you take all the numbers you study in Algebra 1, combine it with numbers you study in Algebra 2, put them together, you get all the complex numbers. Okay, so complex numbers have two parts to them. Okay, they have a real part and they have an imaginary part. This side of the diagram, we did not do the first or second day of class. We can look back, but I don't think that's in it.
No, we didn't. We only did the reals.
We only did reals. Yeah. So now we're adding in that piece on the right. So complex numbers have two parts, a real part and an imaginary part. And they look just like that. Okay,
So it looks like a
so when you write a complex number, there is a certain order. You usually put the real part first, then you put the imaginary part second. So in this problem, if I were to ask you, what is the real part of 2 plus 3i? You would say 2. Yeah, the real part of this is 2. The imaginary part is the number in front of the I. So for this one, what number is in front of I? 3. So the imaginary part is a 3. Real part's 2, imaginary part's 3. When you put it in that order, that's called standard form. So on the test, if I say write your answer in standard form, I'm looking for something just like that.
So if you say standard form, you can like automatically assume it's imaginary.
It's automatically what?
Imaginary?
No. Because you could have something like that. That's standard form. Real part, imaginary part. But what's really the imaginary part there? 0. So generally, when the imaginary part is 0, we don't write it. You can, but we don't. And you would just write 4. So just because something is standard form doesn't mean the imaginary part is there. Right? Could be there, or it could not be there, like that. Technically, this is standard form, 4. There's no imaginary part, so we don't write it. So whether you write this or you write this, they're both standard form and they both mean the same thing. This is a lot more common. All right, so, yep.
So it's like basically the same thing as saying like 4 over 1. Like,
Yeah.
you know.
Yep.
Can you actually solve that problem 2 plus 3i?
Can you solve it?
Yeah. Or would it just be like?
No, that's it. That's a number. That's like saying, can you solve 23? No, it's just a number 23. Yeah, you can't solve that. I mean, if you set it equal to something like 23 equals 4x, now you could solve it. But you can't solve it unless it's an equation. 2 plus 3i is just a number. It's just a number. Now, sometimes you don't have a real part. You're in that box that was on the right-hand side. That box looks like that. Think of the real part as 0 plus 2i. There was no real part. When you don't have a real part, that's called a pure imaginary number. So one thing that we gotta make sure kind of people understand a little bit is this I. That I is a symbol that was invented to be able to do like a square root of a negative number and other things. But that is one thing you can use it for. Now, when you write this in math, actually, yeah, let's think about when you write that symbol. What is that?
Pi.
Forget that it has anything to do with math. It is pi. What's pi?
3.14.
Well, that's connecting it with math. But what is that really? It's a what?
A circle thing.
A symbol. Can you be more specific?
A fruit.
What's
Yeah.
more specific to the symbol?
Symbol that helps
Yes,
you out.
Yep.
Doesn't it like represent the circumference of a circle or something of a circle?
So thinking about it kind of disconnected from math, just at its very basic level, like if somebody looked at that and didn't know about math,
It's a number.
yeah,
It's a Greek letter.
it's a Greek letter. That's all it is. It's a Greek letter.
I didn't even know that.
It's a letter in the Greek alphabet. It's the letter
Everything's Greek.
pi. Yeah.
Everything in math is Greek.
Okay, we use all kinds of letters from the Greek alphabet. Right? We use alpha, beta, gamma, theta. Right? Pi is just another letter in the Greek alphabet. Right? So any question on that? So it is a letter, not in our alphabet, but in another alphabet, the Greek alphabet. Now connect it to math. In math, that particular symbol is assigned a meaning. Okay? When you connect it to math, what is the meaning of that symbol? Right, it stands for the number 3.14, and it keeps going. Okay? So in math, that stands for the number 3.14. So if I gave you a word problem, and you had to pick a variable to represent something you didn't know, would you ever pick this as a variable?
No.
No. You'd say, well, wait, it's a letter, right? Yeah, it is a letter, but we never use this letter in math as a variable. We only use that letter to be 3.14. That's all it can be used for. Okay? If you want to pick a variable, pick X, pick Y, pick another letter, but don't pick the Greek letter pi. Okay? So if you're dealing with like a triangle and you don't know your angles, you would never label that one as pi, unless that angle is 3.14 degrees. Well, then you could. We might use alpha or beta. So any question on why we don't use that as a letter or a variable in math?
No, but like, are there any more things like that?
Yes. So the other thing that's like that is I. Okay? When you are dealing with complex numbers, I is just like pi. What is I? Just start with that.
A letter.
It's a letter. In what alphabet?
English.
English alphabet. Nope, that's not in the Greek alphabet. I don't think it's in the Greek alphabet. So I is a letter in the English alphabet. But in math, I has a special meaning. I is defined to be that number. I is the square root of -1. So what that means is when we talk about I, yes, it is a letter in our alphabet, but in math, it stands for a number. So this is a number in math, just like this is a number in math. Those two things behave the same way. They're numbers. Okay, so that's one thing I think people get confused with. They think of I as the letter. It is a letter, but in math, it stands for something special.
Are there any more things like that? Like not even related to something we're gonna do?
Yeah, like point.
There's other symbols that we use in math that are defined to be numbers. Yeah, there's like the golden ratio. That's represented as a Greek letter. So there are certain things that are reserved. We'll leave it like that.
Okay.
And these are two of them. Okay? So I want you to think of I as a number.
I as a number.
I is a number, just like this is a number. Yes, it's a letter, but in math it stands for a number. And why does this symbol stand for that number? I don't know. Somebody just picked that symbol to mean that number. Why does that symbol stand for that number? I don't know. Somebody
Guess
picked,
we'll never know.
yeah, they just picked that number to be represented by that symbol. Okay? Before imaginary numbers, they didn't have a symbol to do that. So they said, well, what can we pick? Well, let's use I. And whoever picked that, now we all have to use the same thing. If we don't, it gets confusing. All right. Okay. So how do we add complex numbers together? Complex numbers have two parts. The first part is the real, and the second part is the imaginary. Kind of think of real parts as like terms. You can combine a real number with a real number. You can also combine an imaginary number with an imaginary number. So if you wanted to add those together, you can add the A and the C because those are real. I know they're real because there's no I next to them. And I can add the B and the D because they're both imaginary. How do I know the B and the D are imaginary?
There's an I.
There's an I next to them. That makes them both imaginary numbers. So I can add the B and the D, but you got to keep the I next to it so we remember that it's imaginary. So what we're going to do with complex numbers is add, subtract, multiply, and divide. We don't do applications of complex numbers in this class. Okay, the applications are pretty rare that you use in real life, and it's really like engineering and some calculus stuff that I don't even know all the applications for I. There's a whole, if you really want to know like more about I, there's an entire class about complex numbers called complex analysis. So you got calculus, you do calculus, you don't use I in calculus usually, you just do it with real numbers, and then you can do calculus completely over again using imaginaries, and that's called complex analysis. It's a whole class about I.
Not at this school, though, right?
No, not in high school. No.
No, it's okay.
All right, so let's add those two complex numbers together. We've got 3 plus 8i and 8 plus 2i. What's the real part of the first number?
3.
3. What's the real part of the second number?
8.
8. If we combine the 3 and the 8 with that operation, what will you get? 11. Make sure your ones and your i's look different, otherwise you're going to get confused. So you got 11. What's the imaginary part of the first number?
8.
And the second one?
2.
2.
It would be 10.
10i.
And
And when
I.
we combine them, you get 10i. And that's as much as you can do. You can't add 11 and 10i together because one's real, one's imaginary. That's as combined as it gets. Any question on that?
No.
All right, let's try that one. 4 minus 2i plus 3 minus 8i.
So it'd be 7.
So we've got a 4 and a 3, and we're going to add them. So we get a 7.
Negative 10.
And we have a negative 2i, a negative 8i, and we're adding them. So how much is that?
Negative 10. 10
Negative
I.
10i. And could you combine that and say like 7 minus 10 is negative 3?
No.
No, that's real, that's imaginary, that's all you can do. Yep. All right, let's try.
You should do the whole test on these.
Well, there'll be one. There'll be one add, one subtract, one multiply, and one divide.
Okay, that's okay.
How many
Fine,
questions?
that's cool.
Today we're going to do add and subtract.
Wait,
Tomorrow we're
is-
going to do multiplication and division.
Yep, that's part of what we're going to do tomorrow.
Is this test going to be multiple choice?
There'll be some non-multiple choice.
But like, there's going to be some multiple choice, right? Like, not like last test.
There'll be some, but there is
A lot.
some that's not. None of these are multiple choice, I don't think. Add, subtract, multiply.
Well, that would be fine.
I mean, that's
These are
easy.
fine.
Yeah.
Why would you want to waste that? Multiple choice.
All right, so how about if we add these up? What's the real part in the first number?
Wouldn't it be negative
Negative
10?
Negative 3 and negative 7, which is negative 10. And the imaginary part?
Plus
4i.
Negative 4i, 8i, and you're going to add them together. So plus 4i.
4i is 4 i's. Sorry.
Whatever.
Any question on that one? Okay, so that's adding, right? All you got to do is combine the two numbers with addition. Subtraction, pretty much the same thing, except think of it as distributing that negative. Okay, you have a real part of A, a real part of C, and you're going to subtract the two. A minus C. To get the imaginary, you've got a real part of B, real part of D, and you're subtracting the two. So you're minusing the D, and you're minusing the C. Minus the D, minus the C. And what's in the middle here, that can end up being addition or subtraction. Just like if we go back to the last problem, we had one that was addition in the middle, one that was subtraction, and the last one we did was addition. So it can be addition or subtraction, depends on the numbers. All right, so let's try this one. 4 plus 12i minus 3 plus 4i. So think of that negative
Would it
as
be
being
1?
distributed.
1.
So 4, 3, and you're going to subtract 4 and 3. So that's 1.
And a D?
Plus 8i.
12i minus 4i is 8i. Yep. Okay. Any question on that one?
No.
Just gonna-
Okay. How about this one? 3 minus 5i minus 8 minus 6i.
Would it be negative 11? No, negative 5.
So 3 take away 8 gives you negative 5. And what's negative 5i? Minus
Negative 11.
minus 6i.
Aye.
Because this is minus a minus 6, it becomes a plus 6. What's negative 5 plus 6?
1.
1.
1i. When you have 1i, you don't have to put the 1. You can leave it as i, or you can put the 1.
And do I have trouble seeing? Get it?
Yeah, I get it. Any question on that? All right, so earlier I wrote down pi equals, and I told you what that was. What did I write down I equals?
Square root of negative 1.
I equals the square root of negative 1. And again, that is not something you can prove. It's like, prove to me why pi equals 3.14. Well, I don't know why they chose that symbol. It's not something you prove. Another example would be like, why do parallel lines not cross? Well, that's the definition of parallel. They don't cross.
So is
You can't
I,
prove that. So you can't prove that, right? I equals the square root of negative 1. Somebody tried to do this. They didn't have a symbol to do it. And they said, okay, I'm going to use an I to represent the answer. And everybody used that symbol. But as long as we all agree that I is the square root of negative 1, this we can figure out. That's very easy to prove. Okay, so we just said I is what?
the square root of negative 1.
I is the square root of negative 1.
So is that just negative 1?
So that's I. And if we
Square root, it takes you to the square root.
So it would just be negative 1.
So that would be negative 1. Yes. And that's important because when we do multiplication, we're going to end up with I squared in a lot of the problems. If you leave I squared in the final answer, it's wrong. I squared always changes to a negative 1.
Can we get like partial credit?
It depends. If it was a multiple choice, if you show your work on it, you might get partial credit. But if it's a short answer, yeah, you could get partial credit on a short answer. Short answer, it's more likely for partial credit than multiple choice.
Sounds good. Okie dokie.
So any question on that? I squared always turns into negative 1.
Yes.
Okay, so what if you had 3i squared minus 8? And I asked you to simplify that.
So it would be 1.
What did we just say I to the second power
It'd be
is?
negative 3.
1. Yeah, negative 3.
What's I squared?
Would be negative
Negative
1.
1
Negative 1. So that's really 3 times negative 1
minus 8.
minus
So
8.
it'd be negative 3 minus 8.
So that's negative 3 minus
So it'd
8.
be negative 11.
So that's negative 11. Yep.
So why would we do the other problems earlier, like the addition? Why wouldn't we just switch all the i's to negative 1?
Because it's not.
Well,
being
I isn't
converted.
negative 1. I squared is negative 1.
Okay.
We didn't have anything to the second power in any of the problems I just gave you.
Okay.
Those were i's, but they were all just i's. No I squareds. So any question on that?
No.
Okay. All right. So that is the homework. So 55 to 65, that's the converting between the polar and rectangular. And 9 to 14, those are the complex number problems they just did. So you've got a little bit of time. You have about 15 minutes. It would also be a good time if you want to ask any questions. Because our test is on Thursday, I'm not sure about the extra help. I'm not staying today. So the only day I might be able to stay is tomorrow. But I won't know that until tomorrow. Or if you email me, I probably will know later tonight if I can stay tomorrow.